All right, let's go ahead and get started with the proof of concept for battle blocks, with primary focus being block collision and reaction. Logan?
All right, well, to get started, let's kick off the project. We'll start a new Windows game, and we'll call this Battle Blocks. And OK to the solution. Now, the first thing I want to do is get the classes and textures folders set up. So we'll add to the project a new folder that I'll call Classes, and another new folder that I'll call Textures. Now, I have the textures already copied into the working folder, so we'll grab those, move over to our Projects folder, and add them into Textures. Go back to Visual Studio, add the existing items under Textures as Content Pipeline files, and there we go. Just a quick explanation of what these graphics are. The ball is the ball that's going to be moving around the screen, the round object. The box is a perfectly square box. And box wide is a box that's about 60 pixels wide by 20 pixels high. So we're actually going to look at a more simplistic and more complex version of the same collision, one that is locked to a square and one that is capable of providing collision on a rectangle.
Okay.
So, next thing I want to do is get some of our classes set up. So I'll go up to the classes folder and we'll add in a few new items. We'll add in an actor class. We'll add in a ball class. And we'll add in a box class. And to each of these classes, let me spend just a minute and set up the using statements and the sub namespace. So we'll start with actor and we'll strip the class sub namespace off. We'll change the usings over where actor has doesn't have a using for text, and has a using for Microsoft.xna.framework and framework.graphics. And let me copy both of those lines because they're used throughout on all of the other classes as well.
Right.
So we can move down to ball. We can set up its using, though it should not need collections.
It doesn't.
Generic. So we'll just drop in the framework. We'll take off the sub namespace, and we'll make sure that ball extends actor. And now we can look at box. Same deal here. We'll take off text and collections. We'll replace them with framework and framework.graphics. Take down the sub namespace, and box also extends actor. All right, that takes care of the creation of these classes. I do want to spend a minute before we go back into the game and implement the actor class.
Okay.
It's a relatively short class, but this will get some of its basic methods in place that we're going to need throughout the project.
Well, the only implementation that you have in place inside this class is extremely small. I think there's a grand total of 4 lines of code.
Right. The key to actor is the few fields that it holds and the methods that it defines, more so than what it actually does.
Right.
So, with actor, let's add in the 4 fields that we need.
The standard things such as position, velocity, color, and, of course, the most important, our actors list.
All right, so we'll drop in our position, our velocity, and our color. And we also need our static actor list so that we can manage all of the actors. So static list of type actor. All right, so the next thing we'll do is we'll make sure that that list gets created, so we'll add in a static constructor. And what do I have for the, I need to put a name for the list of actors.
Don't worry, I was going to let you know.
I saw you pointing at it. It's like, what could be wrong? And then Visual Studio had the red line. It's like, okay, yeah, something is wrong.
Okay, so obviously we have this static list of actors, so let's go ahead and create a static constructor and, well, create our list.
All right, the static constructor is responsible solely for the creation of that list. So that means actors, and here will be equal to a new list of actor.
Simple enough. Now let's go ahead and make a public constructor real quick where we can make sure that we add ourselves to the list and set our color to white.
Right, because we don't want to end up with a color that is black or invisible.
Right.
So let's put in, first let's take ourselves and add us to the actors list. So actors.add this. And also we'll set this dot color equal to color dot white. All right, now we can move on to the first method that we need, or well, I guess you could say the first method other than a constructor.
Well, basically, we've got 4 methods we're going to be adding here. We've got move, then we have update, draw, and process collision. The interesting thing here is the only implementation that is going to be available inside the actor class is going to be in the move method. Our update, draw, and process collision are all going to be virtual, and we'll override them in descending classes.
Right, we just need to get them defined here so that any actor can call these for any other actor.
That's right.
But their individual implementations will be simply overridden in descending classes. But let's begin with move. So we'll put in a public void move method. We'll take in a vector2 that I'm going to call amount.
With 1 M.
With less M's.
Okay.
And the idea here is that you send in an amount, and then we increment the position by that amount. So in order to perform the move, we say this dot position plus equals amount.
Okay.
Now we need to move on to the virtual methods, first of which is going to be update. So we'll make a public virtual void update method that is going to take in the game time. So we'll make a game time parameter called game time. And then I'll just throw the brackets off to the right since we're not providing an implementation inside of actor.
Right.
Next we need to drop down the draw method. And I'm contemplating just copying all of these because that would make it somewhat faster. Just change their names and the parameters they take in. So if I were to copy update 3 times and then add in or change the second one to draw, and now we're going to need to take in a sprite batch as the parameter, which I'm going to simply call sprite batch. And finally, we'll have process collision, which takes in no parameters.
Perfect.
So looking at that, let me do a quick build and just make sure that there is no errors.
And that is a finalized actor.
So now that we have this actor, we can go and fully set up our game class.
Okay.
Since this is an engine demo more than an interactive demo, that means we now have everything we need to know in order to finish off the entire game class.
Very
Since
cool.
all the updates will be very simple and generic. So to get this kicked off, let's take a look at fields inside of the game class.
We've got 3, well, we've got several, but we'll start out with our standards. Screen width, screen height. Now we've got a ball. Go ahead and set the ball radius here.
Right, just remember that value somewhere convenient.
And of course we've got our standard stuff like a sprite batch, and of course we need some sort of 2D textures to hold the ball texture and the box texture.
All right. So first of those is going to be the screen width and screen height. I'm going to make both of these constants and also make both of them public so that all the other classes can get to them easily. So I'll make the first one public constant integer called screen width, which will initialize to 640, and then I'll copy and paste that line to make screen height, which I'll set to 480. Now I'll add in one more constant, this one not public, and also of type float, which we're going to call ball radius. Then we'll set that to 8, because the graphic that we have for the ball is a 16 by 16 graphic. So that simply matches the graphic that we're going to load. All right, next field will be for the sprite batch. So we'll drop in a sprite batch, again called sprite batch. And now we need to hold 2 textures. Now for both of these textures, I'm going to make them public and static. The idea here is that none of these actors hold texture references themselves, and for the purpose of this example, we're not dealing with texture management. We just want to see things on the screen. So what I'm going to do is make both of the textures public and static so that they're generally accessible. Because if you remember, actor has a draw method. So I do want to have specialized draw code in different kinds of actors, but we'll make it easy so that those things can just look back at the main game class.
Okay.
So we'll drop in a public static texture 2D called ball texture, and the same thing, so I'll copy and paste that line, this time calling the second one box texture.
Very good. Now that we've got our fields out of the way, let's go ahead and jump down to our constructor and set up our preferred back buffer width and height.
Okay,
Just
so
go ahead and get our screen initialized to the proper size.
So down here in our game1, our constructor, let's look at graphics and set the preferred back buffer width to screen width, and the preferred back buffer height to screen height.
Okay. Now we can go ahead and jump on down to initialize. Just get kind of our standard things knocked out real quick. Let's get our sprite batch.
Yeah, there's one method we need to drop in before initialize, because initialize is going to call upon a method that's going to create what I'm going to term the demo
You
scene.
want to go ahead and get the create demo actors in place?
Right. I'm just going to throw the skeleton of it down.
That's cool.
But basically what I'm going to do is by the end of this example, we're going to have several things needing to happen to put together a scene that will let us test everything.
Right.
So I'd rather not have all that code clutter the initialize method. Instead, I'm going to put it off into its own method.
Gotcha.
And that method is going to be the private void create demo actors.
I was just kind of walking through all the standards first.
Right. That's the way we've done very often in the past.
Yeah, you're just sprucing things up, you know.
In this case, I'm trying my best to try to hit everything linearly, where we can go top to bottom in a game class and implement the entire thing, which is probably a first for any video.
I think so. Okay, so now we can jump down to initialize?
Indeed.
So and we can go ahead and get our sprite batch set up.
All right, so let's take our sprite batch and make sure he's set to a new instance of sprite batch, and of course feeding it graphics.graphics device.
And the next thing we're going to do is, of course, call that create demo actors, where we can then take care of all of the stuff inside create demo actors that we would normally do and initialize, but we're just keeping things nice and clean.
All right, so now we should be able to move on to load graphics content.
Yeah, let's go ahead and get our two textures all set up.
All right, so first we'll look at the ball texture, and we'll set that to content.load type texture 2D and asset name textures with the casing more correct, and the first one being the ball asset. Then we could copy that line and change it to the box texture and load in the asset named box. Alright, now we can move on to update.
Okay.
So in update, well, of course we need to go through all of our actors and update and move them. So we'll do a for loop, and I'm going to do a reversed for loop, because later we are going to need to deal with actors that are getting removed from the list. So we need to iterate through the list in a safe manner, going back to front.
Right.
Now we're going to start at the actor count. We'll use that as our beginning point. So for I is equal to actor dot... Is actors not showing up?
Maybe it's not public.
Could very well be.
How about...
I'm going to type it out as though it were, though.
Yeah,
so
go
actor,
ahead.
I know it's supposed to be actor.actors
Dot count. Yeah, you'll see why it's not public in about 3 seconds.
So, of course, we'll hit enter to that, make it accept the template, jump back to actor for just a moment.
Add the word public in.
And that would indeed help. So, public list, now all of this shows up.
Yeah.
Okay, so now we can move into the loop. First thing in the loop, I'll pull the current actor out just to put it in a more easy,
for
convenient
simplistic shape, yeah.
Also for readability's sake, too. So I'll make a variable
That's
called
what I mean, for simplistic, so we're not having to deal with indices and all.
Exactly. So actor.actors sub I. Let's throw that in actor. Now we can take that actor and call its update method, sending game time. And we'll call that actor's move method, and we'll move it by its own velocity. So move by actor.velocity. And that takes care of update.
Okay.
So now we can move on to draw. Instead of draw, I'm going to clear the screen to black, and then we can loop through all of our actors. Well, first we're going to take the sprite batch
and begin.
Call begin.
Mm-hmm.
Then we can do a for each loop, since here at this point we shouldn't be worried about things being removed, since it's update, which would in turn remove stuff. Here we have everything, we're not going to mess with the list, so we'll use a for each. Let's define an actor. They'll be in actors list.
And of course, we're not dealing with a high number of actors, so for each is going to work just fine.
All right. So let's take that actor and tell it to draw. Because, like I was saying before, the different types of actors, the ball and the box, will need different ways that they draw themselves. So we'll just hand that off to the individual class. Now we'll finish all this up where they call the sprite batch.
Go ahead and make sure after you call that in that when we call upon the draw method, we go ahead and pass it the sprite batch over.
Right. So let's make sure that, yeah, of course, on call, that's going to be sprite batch that we need to send over.
Yeah, cool.
All right, now since that is the game class, let me build, make sure that there's no errors.
Okay.
And everything looks good. Velocity isn't in use yet, but that's fine. It's just a warning.
Yeah, technically that wraps everything up with the exception of create demo actors, which we'll be getting to here real shortly.
Mm-hmm.
Okay, so with that, that's going to wrap up this video.